Jumping into test 2 here, the 6 official paper tests on College Board. If you are looking to just skip to the hardest problems, you will see here in the background, as you get later on, I have the harder problems underlined. Do you see that one? So don't look for vertical slashes, look for these horizontal slashes like this. Those are going to be the hardest problems, and I have them outlined in the reading and math modules as you go through these videos. But yeah, this is going to be math module 1 from test 2. Let's go ahead and get started. So number 1 here, we have, let's scroll down a little bit more. We have a line graph. Remember, the first page, first 2 pages, sometimes even up to the first 3 pages aren't going to be that bad. Usually there'll only be like one hard problem in the first 3 pages, but still we want to ace all these easier problems. Let's see what we got. Okay, so I see a graph. I see we spike at 2014 here, and they ask for what model year is the percent of cars for sale the smallest? Looks like it's just going to be C for number 1, right? So these line graphs, they're always going to ask about the spikes, right? They might ask maybe between what years was the spike the greatest, and it'd be 2012 to 2014. When was there the biggest increase, right? And I would look from 2014 to 2015. They just ask for the year in which it's the lowest, so I just go to the lowest point. These are never going to be too bad. For number 2 here, let's change colors. For a particular machine that produces beads, 29 out of every 100 are going to have a defect. That's pretty bad. A bead produced by the machine will be selected at random. What is the probability that the bead will have a defect? Again, really not too bad here. With these ones, it's just good to build a habit of I'm already making my fraction, so the answers I don't really need help from. So if 29 out of 100 are going to have a defect, I make that equation, and then I already look for my answer and it matches. So again, really not too bad, these first couple problems. Number 3 here, let's move this. Let's scroll up a tiny bit more. So we have, this diagram of angles. We should be really familiar with this. The main thing is that we're only going to have 2 angles in this entire diagram. Remember your vertical angles. So I already know that this is going to be 33. Let's make this a little bit smaller. And I know that this is going to be 33. And then I also know that this has to be 180, right? So you got to think, well, what's going to make that 180? This angle right here. And I think it's going to be 147. And then vertical angle, so this would be 147. And then up here, 147. And then this, 147. So these diagrams, they're only going to have 2 angles. I look through my answers and they want to know X, and I think it's just going to be D here. Really not too bad. We'll get into the much, more intermediate and harder angle problems. These ones, easy. Number 4, let's move this back over here. And let's see what we got. So number 4, what is the y-intercept of the graph shown? Again, not too bad. We master our linear equations. We master our graphs or our quadratic equations. And our y-intercept is always just going to be when our x is 0 or when we hit the y-axis. And it looks like it's going to be a positive 8. Don't forget x, y. So it's going to be when our 8 is that second kind of digit there. Okay. And looking at number 5, we have an f of x to lease a car for 36 months from a dealership is equal to 36x plus 1,000. So already pause. Let's master our linear equations. What does this equation mean? I'll kind of rewrite it down below. If my y is equal to 36x plus 1,000. So let's finish the context. X is the monthly payment. What is the total cost to lease a car when the monthly payment is 400? So they make it really easy for us. If this is my monthly payment and we already know it's 400, this just turns into 400 times 36 plus 1,000, right? But I do want to jump into the context after real fast. So 400 times 36 plus 1,000. I just get 15,400 for C. Let's make sure it's right. Yeah. But yeah, so we always want to just be able to master our context. Our y-intercept is going to be 1,000. So it sounds like we are maybe putting like a down payment, right? Because if y is going to be our total cost, or f of x is our total cost, this 1,000 is going to be like a down payment for a lease. And then we're also paying $400 a month for 36 months, right? So that makes sense. Not too bad. And number 6 here, let's shift this. And they say each side of a square has a length of 45. Okay. And I just imagine the rest of the sides are also 45. And they say, what is the perimeter? Really, really, really not too bad. I just do 45 times 4. And I think we're going to get 180 here for number 6. It's very generous of them that, again, your first module, remember, you're going to get a lot of problems like this. At least half of your first module are going to be easier to maybe a little bit more intermediate. And then the other half are obviously going to include some of the more medium and hard problems. Half your test is going to be like this. Don't get tricked into overthinking about these super easy problems. Number 7, and as you can see, I'm starting to outline which ones are going to be in the blue book. I will eventually release a blue book free version of these paper tests, okay? So this is not complete. Do not be like, oh, okay, these ones are the blue books, the other ones aren't, because I haven't gone through all the blue books yet, but I am starting to outline which ones are which. And what I'll also do is I think I'll also make a blue book test that is all the blue book problems that aren't on the paper tests. That way you're not kind of, it's not that big of a deal to kind of see problems twice, but it is nice to kind of see fresh material, you know. For this one, I have an immediate reaction. As soon as I see my equal sign, I can make a second fraction, I can cross multiply. But I also could try something else here, right? You almost have to, those of us that are kind of more on the solving side, you almost want to pause sometimes and say, well, we're allowed to use a certain tool here, aren't we? And that's Desmos. So on these ones where we're maybe more inclined to solve, you can still solve, but like there's nothing wrong with going and opening up Desmos and plugging in a function to just see what we get here. And I definitely see something. I see my x, 4, 5, my x could be equal to 6 here. And let's get rid of Desmos here and see if that could be true. So for number 7, did I misread that? Let me reopen my Desmos real quick here. It could be that I have to zoom in more. Oh yeah, so it is equal to 5. So Desmos can be misleading there. My scale was actually 0.5. So when you saw 2 increments, it was actually 0.5, 0.5. So it was actually +1. So 5, you can see it here now. That is obviously much faster than solving. And it also, it's ironic because it looked like we could have made a little error there. Make sure to just zoom in on your points to where you can click on it and then it'll actually tell you what the point is, because Desmos will on average lead to just less mistakes than if you try to solve by hand. You might miss a sign, you might miss a multiplication or a distribution. Really not too bad there. If I did want to solve this by hand, I would just cross multiply here. And so I'd get 55 is equal to, see, like this does not turn into the funnest problem. X squared plus 6x minus 55. I would have to factor here, right? Factors of 55 that add or subtract a +6. Much nicer to throw that in Desmos. And number 8 here. Let's see what they want. Let's get rid of this little bit here. So number 8, an object travels at a constant speed of 12 centimeters per second. Even though this is an easier problem, I want to get in the habit of writing down my units and my rates. What is the time that it will take for an object to travel? 108. So again, I always want to be organized. Let's shift it over a little bit. So if this is going to 108 centimeters, I want to make sure to match my format. I have a nice big question mark down here. I don't know how long it's going to take, but what fits in here? Never think of our relationships as additive. They're always going to be multiplicative. That is, there's always going to be something that's multiplying that's changing a relationship. So I just say, what is multiplying by 12 to get 108? And it's 9. So if I multiply by 9 here, I should multiply by 9 here, and I should get 9 seconds, or A for number 8. Again, even though these are some of the easier problems, they still help reinforce our ability to build these habits, these strong organizational skills that we want for the harder problems. Let's jump down to number 10. Or number 9. And it looks like it might be like a mean, median type of problem. Let's see. We have data set X and data set Y. So I do notice that these have the same first 4 points. And then this one has just a 27 added on. Which statement correctly compares the mean of data set X and the data set Y? So this is pretty easy. You could find the means of each, but if mean of X is, we'll just give it like 10. The mean of Y is what? And it's just going to be greater than 10, right? because they're just throwing in a 27. So it's going to really curve up my mean. They could change this problem to range. Throwing in the 27 is going to really increase my range. My median, that I would have to figure out what my middle number is. It might not even change by much. So my middle number is going to be 9, and my middle number is going to stay 9. So you can see how this could get tricky if they changed up what type of problem. Mean, super easy. Mean of y is going to be greater than x. So let's look for that one. Nope. Oh, right here. So they do, look, they even mix up the wording. The mean of dataset X is less than the mean of Y. Let's make sure that's right. It is. So not too bad of a problem there. Number 10. So we'll probably just try to finish up this page. We might even finish right before 14 because that's going to be a really good problem to start next module with. So a rocket contains this many kilograms of propellant before launch. That's going to be a weight. 21 seconds after launch, that much remains. So, okay. So if I'm thinking of kind of like a graph here, right? We are starting at this 467,000, right? And this is going to be at time 0. At time 21, it looks like we kind of go down. And I know my graph's going to be a little bit misleading here, but to about here. And then now we are at this 362,000. So what I'm picturing, what I'm imagining is this probably is going to be a linear relationship. We start with this much fuel, we drop to this much fuel over this much time. Approximately how much propellant did it burn each second? So they're just trying to find a number that's not too hard to discover here. I want to look at how much time has passed, and I want to look at how much loss I've had of kilograms, right? So if I've lost 467,000 minus 362,105, I've lost 104,895 over 21 seconds. So you can see it's not that bad. I organized my problem just because I think it helps to kind of master like what is happening here. I write down my two changes. I've changed 104,000 in my y. I've changed 21 in my x. And I do this division here, and I get about A. Not even about, exactly A. I'm losing that many kilograms per second. We make sure this one's right, and A is correct for this one. So I still think, I know these problems are a little bit on the easier side, but they are excellent for reinforcing these skills, these fundamental skills. And number 11, let's see what's going on here. If 4x plus 2 is equal to 12, what is the value of 16x plus 8? Always look for the shortcut. They multiplied this and this by 4. So if I multiply this by 4, I can also multiply this by 4. And I would get 16x plus 8 is equal to 48. There's going to be tons and tons of little shortcuts like that. Of course, you could just solve for x. It would probably only take you a couple seconds longer. But it's almost... they're trying to almost gear you to look towards these problems with a certain kind of like riddle solving mindset, because of course this is an easier one. You can solve it without figuring out that little riddle they had, but it's trying to prepare you for the medium and hard problems where the riddle is harder to solve, right? Not too bad. Let's finish this page. Number 12 up here. Okay. And a physics problem. These are fun to kind of picture. If I try to draw this, let's see what it looks like here. So an object is kicked from a platform. So when time is 0, we're starting at 9. And I'll probably put the 9 like up here because I don't want to get in the way of my parabola. So at time equals 0, we're at 9. And it is a negative parabola. So maybe it's going to look something like this. And you might be saying like, why? I almost want to try to help. Like we're going to get rid of this side of the parabola. And it's because what's happening, graphically, and then what's happening in the context are kind of two different things. We are considering our x-axis to be t, which is time. So we really only care about when the time is positive here. They're not going to acknowledge this left side of the graph. So again, graphically and contextually, they're two different things. We care about this positive time of the graph. So let's see what is happening here. Where the height of the object is above the ground in meters. So meters, t seconds after it's kicked. So meters is going to be our h. That's going to be this. and then t is going to be time. That's going to be our x. What number represents the height from which the object was kicked? So again, we already know this. It's going to be d for this one. Picturing these can really help. They can ask about multiple things with these kind of physics parabola problems. They might ask about the vertex, where they will say, oh, what was the maximum height, or what was the minimum height at some point during this? That's when we look for the vertex. That's where we can throw this in Desmos. I drew it here, but don't be afraid to throw this in Desmos to kind of see what it looks like. They could ask about, when time was 0, or at what time it hits the ground. That's going to be maybe our x value here, right? So they can ask about a bunch of different things. We will see all the different ways they ask these physics types of problems if you follow through all these videos with me. And that's the whole point of this experience, right? It doesn't matter if I'm helping you with these problems. It doesn't matter if you're seeing them all for the first time. If you go through 100, 500, 1,500 practice problems, what you're doing is you are seeing all the different ways that the humans that make the SAT, the way they're able to kind of diversify their problems. So when you see your next SAT, there's only so much they're able to change the context, the names, the numbers, but they're going to resemble these problems, and you're going to know how to solve them because of this practice. So let's finish this one. This one might have been a decent one, back when you had to factor on the SAT. I see a function, I throw it in Desmos. Let's open up Desmos real quick. And let's plug this in. So I get 4x to the second minus 50x plus 126. And you already know that it's a parabola, so I'm going to be looking for my x-intercepts here, and I'm going to zoom in, and I'm going to avoid the mistake I made earlier. So I'm going to write these down in the background. I see 3.5, and I also see, I think that's a 9. So we'll hide Desmos. Oh, they did say reach its minimum. So that was, me overlooking the problem. They asked for the minimum. I didn't even need the x-intercepts. I go ahead and zoom a little bit out again. Work my way towards the bottom here, and our minimum is going to be, it looks like -30. Oh, wow, -30.25, I'm thinking, right? -30.25. And let's just confirm that with my answers to make sure. And I get, oh, I overlooked it again. So they ask, so this would be true. This would be its minimum here. Let me hide Desmos real quick. So this would be its minimum. These would be my x-intercepts. They ask for what value of x does f of x reach its minimum. So you can see, even with these easier problems, even me kind of overlooking, trying to record all the data I can, if I reopen Desmos here, the x value at which, and you can kind of already see it's going to be between 6 and 6.5 here. It's going to be 6.25. You can find that out in various ways. If I did plug this into my equation, it would give me my x value. Like if you plug in the y of your vertex, it would give you the x of your vertex. I could also find what's between this. That's another big point to remember. The x of your vertex is between your two x-intercepts because it is a symmetrical graph. So it does look like it's going to be 6.25 here. Great to practice these problems. Number 14 is going to be a really good one to start with, so make sure to jump back in for part 2.